Okay, Assalamualaikum dan selamat sejahtera. Jadi selamat pagilah, salam Malaysia Madani. Jadi selamat datang ke Bengkel ataupun Taklimat lah, Pertandingan POLYCC League of Large Language Model pada tahun 2024 Peringkat Saringan. So saya Akasha sebagai host lah dan moderator pada pagi ini, dan juga kita bersama saya ada Mr. Kwan dan juga Mr. Aswin selaku Solution Architect daripada AWS Malaysia. Jadi bengkel ni akan berlangsung daripada pukul 10 pagi selama 2 jam lah sampai pukul 12 lah. So kita harap kita dapat menghabiskan dalam masa 2 jam lah. Okay. Jadi untuk sebelum tu saya nak minta yang tengah online pada hari ni, pada pagi ni saya tengok ada 100 lebih. So saya nak minta bantuan lah pada yang online pada hari ni untuk subscribe dan share lah. Share channel EduTV POLYCC lah. Share ramai-ramai lah. Saya nak tengok nak tengok. Saya tengok kalau saya check YouTube ni, tengok kalau ada meningkat, saya memang gembira lah kita nak ramai-ramai tengok. Dan juga kalau ada yang antara mereka yang masih ada kelas kita buat ni waktu PDP. So okay. Ada waktu PDP, ada yang tengah meeting ke, persyarat tengah meeting ke. So jangan risau sebab kita buat di live YouTube dan ini akan automatically dirakam lah. So boleh dirujuk pada bila-bila masa. Asynchronous orang kata. Okay. Jadi so saya minta lagi sekali untuk subscribe dan like dan share lah pada tu yang grup yang lain tu, yang grup di institusi politeknik dan juga college community. Jadi dan kemudian saya nak ucapkan terima kasih di atas sokongan warga POLYCC yang terdiri daripada pesara dan juga pelajar. Jumlah pendaftaran berjumlah 500 kumpulan 500 grup. Memang orang kata mendapat sokongan yang padu lah daripada POLYCC ya. Jadi saya dengan ini nak ucapkan terima kasih lah kepada pengarah, timbalan pengarah, ketua program, pensyarah di POLYCC kerana support BIPD untuk pertandingan LOL 2024 ni. Okey, terima kasih. Jadi untuk pengetahuan semua, pertandingan LOL 2024 ni dilaksanakan seiring dengan pertandingan idola yang ke-12. So untuk pertandingan idola ni kita ada satu tema lah. Tema apakah temanya? POLYCC Artificial Intelligence Reform Agenda PAIR lah 2024 sehingga 2030. So kita ada kat sebelah tu yang bulat tu roti canai tu, kita ada Tibet Digital. So adalah kata salah satu inisiatif BIPD untuk mendigitalkan politeknik dan kolektiviti lah. Okay. Di situ juga kita ada 4 strategi. So ada 4 strategi. So yang LOL ni kat mana? Kita buat di untuk apa ni? Untuk hub untuk yang apa? Pembelajaran di cloud lah. Okey. Jadi untuk penceramah bengkel pertandingan ni kita ada 3 orang lah, 3 orang yang core team dia. So yang pertama kita ada Mr. Kwan di sini dan juga kita ada Mr. Aswin, Solution Architect, daripada AWS Malaysia, dan kita ada core team daripada Singapura, iaitu diketuai oleh Mr. Vincent, Senior Specialist Solution Architect. Dia memang hebat dalam AI lah. Kalau tengok LinkedIn dia, boleh search lah LinkedIn kat situ, boleh connect dengan dia. Dan kemudian kita ada Natasha Idris, merupakan Senior Technical Program Manager ASEAN Public Sector lah daripada AWS. So kedua-dua orang ni adalah merupakan core team daripada Singapura yang di mana untuk makluman puan-puan dan puan-puan yang online sekarang ni, pertandingan LOL ni dah berlangsung pada Mei yang lalu di Singapura, kali pertama di Singapura, dan kemudian ke Vietnam, dan kemudian di Malaysia. Tengok dia punya timeline amat tight, dan dalam masa sekejap mata je kita JPKK diberi peluang lah untuk melaksanakan pertandingan LOL ni 2024 di pertama di Malaysia tau. Kita yang first yang buat ni. Okey, saya nak ucapkan terima kasih kepada AWS Malaysia, AWS Singapura dan AWS Worldwide lah. Kerana bagi peluang kepada JPKK untuk host pertandingan yang unik ni. Yang pertama sekali, pertandingan apa? Pertandingan generative AI kan. So harap tuan-tuan faham lah apa maksud generative AI tu. Kalau tak faham, kena pergi kat YouTube channel kita, nanti ada penerangan video di situ. Okey. Jadi proses training ni boleh orang kata untuk pertandingan ni kita boleh berlaku di mana-mana saja pada bila-bila masa. Okey. Disebabkan AWS console tu lah. So dan suka saya nak ingatkan tempoh pertandingan ni ni special sikit. Tempoh pertandingan kita ni berlaku dalam bulan berdekah.
Apa tu kan?
Tengok tu saya ada buat kan.
Kali berdekah.
Ni saya generate pakai ChatGPT lah. Tengok dia punya belakang tu kan. Okey. Jadi tarikh dia 13 Ogos sehingga 3 September 2024. Okey, dengan itu saya stop sharing saya punya slide. Dan kita nak buat borak kejap lah. Sementara Mr. Vincent tengah bersedia tu, saya tak boleh ni pula. Jadi saya apa yang tadi
mungkin sebelum tu Cik Kasha tadi nampak banyak perkataan LOL ni. Ni kita gelak ke macam mana?
Tu lah orang ingat kalau yang zaman saya lah, zaman 80s kan kata RIC, Yahoo Messenger, LOL tu apa gelak-gelak kan.
Bapak ulang kan.
Jadi dia mau macam mana? Dia mau?
Kita LOL aja lah. Jadi mungkin kita tanya Cik Kuan apa tu LOL
LOL dari segi pertandingan yang julung-julung kali diadakan di Malaysia ni, terlebih dahulu untuk pihak AWS ni kita sangat berbangga sebab dari segi boleh diberi peluang untuk melaksanakan untuk melaksanakan pertandingan ataupun aktiviti LOL atau kita panggil large league of large language model. Sekarang JPKI ini kan ialah apakah model AI yang dibangunkan untuk mendukung inisiatif JPKI adalah large language model lah. So kita sangat banggalah diberi peluang untuk bekerjasama dengan tim JPKK dan juga tim POLYCC, especially untuk melaksanakan aktiviti ataupun event lah POLYCC LOL 2024 sempena dengan idola yang ke-12
dan bulan Merdeka sekali.
Apakah kita projek lagi kan? Adakah Saringan Peringkat?
Saringan ni kita ada, maksudnya Saringan ni kita akan pilih lah finalis. Jadi satu wakil daripada sejak institusi. Maksudnya kalau poli satu wakil. Poli kita pilih poli poli alam kan contohnya. Satu poli satu tim. Jadi kita akan pilih 5 tim atau 6 tim. Jadi semua akan ke final dan kita akan adakan pertandingan ni di Dewan Zakbar di KPT Persen 5 lah. Di mana dia punya pertandingan ni dia ada style macam AF. Akademi Fantasia. Ada voting tu. Maksudnya juri bagi markah.
Memang glamour lah.
AI pun bagi markah. AI yang bagi markah. Panel expert pun bagi markah. Student pun boleh markah. Okey, jadi kalau nak tahu kena stay tune lah untuk taklimat dan workshop ni. Jadi saya rasa Mr. Vincent dah ready kot.
Okay.
Mr. Vincent, please say hi. So Mr. Vincent, saya nak minta izin semua, Mr. Vincent akan berkomunikasi dalam bahasa Inggeris. Jadi jangan risau, jangan apa kata alamak macam tak faham ke apa kan. Apa?
Jangan malu lah.
Jangan malu lah nak bertanya. Dan kita pun ada sediakan di peringkat DPK ada sediakan grup WhatsApp untuk Secara, grup WhatsApp untuk Talian. So kita akan support lah anda semua kalau ada yang tak faham, dan kita cuba bantulah supaya semua orang faham pasal LOR ni, iaitu AI, pertandingan generative AI yang pertama di Malaysia. Okay, Mr. Vincent, say hi please.
Hello everyone, good to see you. So happy and privileged to be part of the POLYCC LOL competition. First time in Malaysia and first time in Asia. Very, very exciting.
Okay.
And
okay, so Vincent is our main core team who will be doing the briefing today. So Vincent, maybe we pass the floor to you. Thanks for the introduction, and you can share with the team on how do we launch this in the workshop. Over the floor to you, Vincent.
Let me share my screen and then okay, let's go. Give me a second. Okay, let me know when you can see my screen. Let me. Can you see my screen?
Yeah. Good.
Is it okay?
Yeah.
Okay. Okay. Hi everyone. So once again, I think I hear some echo. Let me there's an echo on the testing. Okay, this is better. I think there's echo coming from Kwan your side.
Let me see.
Maybe we mute. Yes. Testing. Okay. Let me see if it's better. Yeah, there's a bit of I need help to mute your side when I'm giving the work when it's the workshop part.
Yeah, I think they are checking, so we are rectifying, so no problem.
Okay, thanks a lot. Thanks a lot. Okay, now I'll just get I'll just get started first then. Okay, hi everyone. My name is Vincent. Thanks Akasha, Kwan, and Ashwin, POLYCC, MOHG for having me. So my name is I'm a specialist solution architect. Essentially, what I cover Gen AI and also innovation, emerging technologies for ASEAN in public sector. So I work a lot with schools, with our government, with healthcare to deploy generative AI solutions for public good. So this is a program that we came up with called the League of Large Language Model, which is for AWS Law, like you heard earlier. So it's a competition that gives everyone a way to have fun, at the same time being able to learn on generative AI, fine-tuning, which is a top exciting skill set to have, regardless of the domain that you are in. So on the side, I teach as an adjunct professor. I'm an educator myself as well. I teach as an adjunct professor in Singapore Management University. So it's really, really glad to be able to connect with all the students, lecturers, teachers across POLYCC in Malaysia. So let's get started. So today, what we're going to be having is that it's going to be fun, right? We want to learn, but we want to learn in having a fun way. So I'll be sharing about what is LOL, and then after that, in a nutshell, I will show you some examples of one of the most recently ran events that we had. And then from there, we'll deep dive into, you probably are thinking of hearing of the word tuning for the first time. So we'll peel the onion and let's look at what exactly does it mean to tune a large language model. We heard a lot about tuning a car for performance, for racing, right? What about tuning a large language model? So we're going to look at that. And then from there, we'll explore the tuning process, the whole end-to-end process, as per how an industrial data scientist will be learning. So the skills that you're learning today is not something that's amateurish. The process you're going to be learning is going to be wonderful because you are going to be stepping through the lens of what data scientists in like Netflix, in Facebook, in Apple, in Amazon, what we go through when we actually do tuning, right? So all these, the same things that we go through are the same process that you're going to get access to today. And then from there, today we have 500 teams. So it's going to be a competition. So what we're going to have at the start is that there'll be a moment whereby we'll break out for hands-on workshop where every single team over here, we have 500 teams today. From what I last heard from Akasha and the team, organizing team, we have 1,500 people. So we're going to have 1,500 of you tuning a domain large language model using AWS technology. Right, but of course, to do that by first having a demonstration. And then after that, you're going to be having, just like if you have joined last year's Deep Racer, you'll recall that there's a leaderboard where you can submit your model to see how your model performs. So you can submit your model to a leaderboard, and then from there, you can see your score appearing. And then from there, before the end closing up of today, the organizing team and myself will share with you what are some of the next steps that you can take on to improve your model, and what are some of the other competition details that you probably want to be mindful of as you're preparing for the competition. All right, so let's get started. Now, you probably might have heard of large language model not for the first time, right? Because generative AI, ChatGPT, it's been kind of like the hype for the past 1.5 years, right? So, but what people doesn't know so often is how do we actually get to customize a model, especially when you think about when you start to go into an enterprise setting, you can't just use the model as it is. You want to customize it such that it's able to use it in a specific setting. For example, like education or healthcare or finance. So there's a few approaches. Now, the first approach is that you probably heard about it, and even some of you students here, you might have learned about it in your courses, is that you can apply what we call prompt engineering, which is essentially how you prompt the model to get a better answer. Second approach is that you can apply what we call retrieval augmented generation, which is essentially fetching data in runtime to augment your model. And then there's a more kind of like the more hard to apply concepts or much more complexity concepts like fine-tuning and continued pre-training. And this is where typically where data scientists comes in, where they begin to apply data science skills to begin to tune a model at the model's neural network layer to get it to perform in a certain way. Now, the idea is that you can see over here, the idea is that as you begin to go further, the complexity begins to start to increases and it becomes more challenging in terms of cost and time. So it's because of this, that's why we launched AWS LOL, which is the AWS League of Large Language Model. So what you're seeing over here is Lola. Lola is our mascot. She's a llama for the competition. So essentially, AWS LOL, we want to bring together participants across all kinds of background, technical, non-technical, to be able to compete in the competition. Now, so this is the experience that you'll be experiencing. So the goal of LOL is to really, how can we democratize machine learning, enable everyone to become not a data scientist, right? But really, how can we enable everyone to be able to be adept in tuning domain large language model? And we are looking at people who have zero technical background. So if you are thinking today, hey Vincent, I never touched coding before. I never written a single line of code before. I don't know what you mean by that. So what I want to say is that even if you didn't come from a technical background, you still be able to be adept in tuning large language model after you go through AWS LOL program. All right. So this is how the program overview looks like. It's going to be a 1.5 hours workshop, which is what you are experiencing here, 1.5 hours to 2 hours. And in this workshop, you'll be hearing about fine-tuning, you'll be hearing about model evaluation, you'll be learning how to prepare your data set for fine-tuning, and then you'll be creating your first model today. So all of us here, by the time you step out of today's workshop, you have tuned your first model, right? In that under that 2 hours. And after that, what's going to happen is that over the next 2 to 3 weeks, we have 500 teams for the POLYCC law competition. So you have a virtual leaderboard where you can essentially submit your model to the leaderboard. And from there, your score will begin to appear. So think of it just like your arcade games, right? Where you kind of like try to beat out the best score. So it's the same concept. You submit the model and your model will begin to appear on the leaderboard. And the best models on the top will be shortlisted. And on the far right hand side, there'll be a finale game show. So if I'm thinking, now what do you mean by game show? So if you think about some of the game shows that we have in Malaysia, in Asia, like Wheels of Fortune, Who Wants to Be a Millionaire, Malaysia Got Idol, all this kind of like a game show or reality show, right? So it's going to be something like that, where we have a finale game show where there's going to be physical, and only the top 5 teams will be shortlisted to essentially battle out for the final law championship in POLYCC 2024, right? But what's interesting is that in the finale game show, everyone will still have a part to play, which I'll talk about that later on. But essentially for the finalists, it's going to be the top 5 teams that will be identified and shortlisted through the virtual competition. Now, showing is better than talking. Let me show a quick video. Let me just reshare my screen again so you can see how it was like in one of the most recently ran competition, right? So let me just play the video. Okay, let me play the video. Awesome, right? So let me just go back to my slide. Okay, let me just go back to my slide. And here, okay. So what you've seen earlier is you saw a sneak preview of what we ran recently for AI Singapore. So they are like just like POLYCC, they are a student body, and they didn't have as many people. They have about 200 plus people, and it came together to compete to build the best model. And that what the video you saw earlier was a finale where everyone came together and the finalists was there, and you saw the game show, and then there was attractive prizes to be won. So the idea is that at the end of this 3 weeks, 4 weeks program, about 1 month, the idea is that you get to experience a gamified approach to generative AI, and you get to learn 2 key things, which is a very, very important skill, as what just now Akasha has shared earlier in your roadmap to your AI skills uplifting, right? And one of the big part is around model fine-tuning and model evaluation. And this is the top skill that you'll be learning today. And that is something that not even in university sometimes is being covered, but you'll be learning the skill through the LOL program. And of course, through this, we want to foster team building and competition. We know that you are in your teams, in your schools, with your lecturers. So we also want to use this time to for you to have fun and bond with your teammates as you begin to fight for the championship in the competition, right? Now, so to share an example, in the most recently ran AI Singapore competition, we have 263 participants. Over 3 weeks, they trained 2,000 over models. So I'm definitely expecting a lot more when it comes to POLYCC, since we got 1,500 participants. And what they did is that they actually they used a small model, and they trained it so well that the small model was able to beat a bigger model 93% of the time. So you normally, when you hear of generative AI model application, is that the bigger the model, the better it is, right? But what happened over here is that in the low competition, the participants, they actually trained a small model, not very big, 7 billion parameters model, but the model was able to beat up the bigger model by 10 times, by 93% of the time, right? So that is the impact of fine-tuning. When you're able to fine-tune a model and make it very, very specialized, a small model can beat a big model. Right, let me just type yes. Now, so with that in mind, that is the introduction out of the way. Let's go into let's introduce what is large language model performance tuning. And this is, I'm cognizant that not everyone is aware of the various concepts of LLM, so we're going to peel the onion a little bit. So if you think about generative AI application, generative AI is one of the fields under AI, right? So AI, you have a lot of fields, right? Of course, you have your regression model, you have your vision model, and generative AI is one of them. And under generative AI model, you have then multiple different kind of generative AI model. So of course, you have your image models, and large language model, of course, is the most popular one. And under the large language model, essentially what it does is that when you are given a sentence, for example, I want to eat in Kuala Lumpur, this sentence, the LLM will predict what is the next word that will most likely come out. And essentially that cycle goes on and on to generate the full text. So with that in mind, there's a few techniques that people can apply, organizations can apply to improve a model to behave in a certain way. So one way is prompt engineering, as you saw earlier. Second is RAG. Third way is agents. And fourth is fine-tuning. We're not going to be looking at all of them in detail. Today is not about covering the whole 101 of generative AI, but we're going to look at it at a high level. How do they differ? What is the what is the difference between the 4 different techniques if you are listening to these different techniques for the first time. So the first one is prompt engineering. So let's take an example, right? So let's say you have a model, which is look like this, right? You have a model, a large language model. So in prompt engineering, what we have is that we have a prompt, which is what are you going to tell the model, which is typically an instruction. So over here, I will tell the model that, okay, you are an AI movie review classifier. Given a comment, you rate either positive or negative, and here is some example. Oh, awesome is positive, bad is negative. Wow, the movie was solid, right? Boleh, right? Positive, right? So now, this is what we call a prompt, and a prompt is essentially a combination of instructions, examples, and context they provide to the model before the user even asks a question to influence the output. So think of it like an instruction manual you want your model to follow, right? Now, so when the user asks a question, oh, this most latest movie, what a horrible show. The model will then, based on the prompt template and the query, you then say, okay, I am roughly certain that 80% this is a negative movie review. So essentially, this is what prompt engineering does. And you can apply this technique to 1,001 ways of different kind of use cases. Now, the second approach is RAG. Now, RAG is same thing. You still have a prompt template. So like this one, right? You are an AI, for example. So over here, we're all looking at like a example, right? You are an AI supporting a call center agent. And then you provide information from context. If you don't know, you say that you don't know, right? So, for example, let's say all of us here, we have some form of bank cards, right? Probably. What is the cashback percent for a given card? Now, typically, what's going to happen in RAG setting is that this information will not be held within the model. The model will go and search and retrieve information from the bank's repository. So think of it like your SharePoint, your Google Drive, your OneDrive, your Microsoft Teams. These are places where files are being stored. So the model will search and look for the files that contain information about the cashback percentage. It will retrieve that information like just like Google search. You will then make sense of that against the question. It will then provide out the output. Okay, I'm 90% confident that this is 2% from what it finds. So this is RAG. That's why you hear the word retriever augmented. So you're augmenting the query by retrieving additional information during the runtime, during the query itself, right? So that's the second technique. Now, the third technique is what we call agents. Agents still, again, the same thing. In every model setting, you always have a prompt. So I have a prompt. You're an AI supporting a call center. Your nature is talkative, yada, yada. Now, imagine there could be a different kind of query. The first kind of query is what is the cashback percentage? But the kind of query the answer doesn't change very often. For example, the cashback percentage for this card, as long as it probably is going to be the same for the next 1 year. It doesn't change that often, right? It's quite fixed. But if you think about a question like, hey, how much money do I have in my bank account? Now, a question like this can change it every time, every moment, right? The moment you withdraw money, the moment you pay something with your QR code, your savings account dollar is going to change. So with agents, what happens is that the model will go and call a bank system through something like an API. So it could be the bank system API, the deposit API, the withdrawal API, which is essentially a way to communicate with the bank system, right? And then you get back the latest amount that this person has. You then say that, okay, I'm 90% confident that you have so and so amount in your bank account. So this through the agents technique. Now, each of this technique, we can spend 4 hours talking about it, all right? But we're not going to go very deep into it, just to call it out, to let you appreciate, if you're listening to this for the first time, that there are multiple ways that you can actually influence a model, right? And the last part is the fine-tuning, which is what we're going to cover in deep dive a bit more today. So again, you have a model question. They say, okay, you are an agent, you are an AI supporting a call center, and so on and so forth. There's a question they come in and say, hey, can you explain this charge on my latest bank statement? And what should I do next? So when you apply fine-tuning, what you are able to do is that you can fine-tune the model to respond in a certain way. For example, 93% confident there's this reason and this resolution. And you can see over here, my model don't exactly have to go and retrieve information from elsewhere, because the information, the knowledge, the instruction is already embedded into the brain itself. It's inside the brain of the model. So the model may or may not have to go and communicate with an external system. In many cases, they can just answer after this, right? So that is the power of fine-tuning. And typically with fine-tuning, you can increase the control, you can increase the accuracy, you can increase the speed. Because with a small model that you saw earlier, a small model can beat out a big model if you fine-tune it good enough, right? So we've seen that a lot of times if you follow the generative AI news in the global arena. Now, I like to always, I teach as a professor in university, right? So I always like to use analogy to help my students to understand. Now, let's take an example of an analogy, right? Something that we are all very familiar with. I'm sure in Singapore, in Malaysia, in New Zealand, in everywhere, it's a common thing that it's not easy to become a medical doctor. You typically got to have straight A's in your high school, in your A-levels or whichever, right? Now, let's imagine a scenario where you want to, from a high schooler, the process to become a medical doctor. So normally what happens is that the high schooler first, obviously need to be very, very smart, right? Now the high schooler will need to go through a medical school, typically. And in Singapore, it is about 5 years. And then after that, they need to go for residency for another 4 years before they become a doctor. I'm sure it's not too different in Malaysia as well. Right? You need to go through school, then there's residency. So if you and that is typically a long amount of time. But basically what happens is that after they go through the medical school, the high schooler will have the medical domain knowledge inside his or her mind, right? His brain, because he or she has been trained on medical knowledge. So the thing about model fine-tuning, it's the same thing. When it comes to fine-tuning, we are not training from scratch. We are taking a model that is already quite smart to begin with. But what we are doing is that we are just doing some fine adjustment, right, to add on extra specialty to the model's brain itself. So just like how a high schooler that is very, very smart specialize further to become a medical doctor, we're taking a model that is very, very smart. We fine-tune it, it becomes even better in a certain specific domain. For example, in investment, in healthcare, in education, as a teacher, so on and so forth, right? So that is what we call fine-tuning. Now, but we can all agree that after school itself, the doctor is not yet ready to become a doctor. Typically, what they need to do is that during their practice, they need to rely on real-time information. In my family, I have my relatives who are doctors themselves. And they told me that sometimes, when it comes to things like your antibiotics prescription, it can change over time. Today is based on your body weight, this is the amount that they need to prescribe. But tomorrow it may change depending on the regulation. So similarly, a doctor can be trained and then needs to rely on real-time information. A model also, while it's very, very smart, he also needs to rely on real-time information to perform some of his tasks, like the example that you saw earlier. Now, the third thing is that a doctor can be very, very smart. He has real-time information, but we can all agree that, let's say you go to go and visit a doctor or a person, and the doctor asks the person about what's wrong with you. And if the person has stomach ache, but he say that I have headache instead of saying I got stomach ache, even if the doctor is very, very smart, right, or if it's a Nobel Prize winner, he or she will not be able to prescribe the right medicine. So in this case, I'm trying to call an example, right? Just like a model, just like that example, how we ask the model the question is as important as how are we getting the information, the query to the model. And this is where prompt engineering comes in. How do we get the question and the answer and the user query to the model in a way that the model can best provide the best answer? And that's the third technique. And of course, the idea is that in the combined fine-tuning, RAG, prompt engineering, you get a doctor that is very, very good at whatever he or she does. So the idea, what I'm trying to say here is that fine-tuning, RAG, and prompt engineering and agents, all these different large language model customization techniques, they are not mutually exclusive. You might be hearing that, oh, I can just do this, I don't have to do the other one. Now, in the best case, best practice is that when you begin to apply all of them and combine them together, you will get the best result for your application, for a project, or when you go out into the enterprise. If you were to work on Gen AI projects next time, when you begin to combine these multiple techniques together, you can get the best result. Now, so with that kind of like high level out of the way, now let's go deep into fine-tuning, right? So I hope you appreciate prompt engineering, RAG, and also agents. If you want to find out more, you can feel free to look it up. But today the focus is going to be on fine-tuning, which is what the competition is about. Now, to go back a bit more to again, let's talk about why is fine-tuning so important. If you think about, say, take the most recent example, right? GPT-3, OpenAI, they came out with GPT-3, right? And before that, of course, they got GPT-2 and GPT-1. Now, if you think about it, what GPT-3 that gave birth to ChatGPT has been around for quite some time. But no one paid attention to it, right? No one was paying a lot of attention to GPT-3. Most of us, the first time you hear about generative AI is when you've heard about ChatGPT, right? I'm pretty sure for all of us, even for myself, even for us who are in the tech world, the first time when we heard about generative AI, it was through the application. So it was ChatGPT that actually captured the attention of the world, not GPT-3. And you think about it, what is the difference between ChatGPT and GPT-3? Because ChatGPT was born out of GPT-3. The key thing here is that ChatGPT is actually a fine-tuned version of GPT-3. What OpenAI did is that they take GPT 3.5 model and they fine-tune it a lot with chat information, with chat dialogues to make it very, very, very good at chatting. And hence you get a fine-tuned chat model. And then the rest became history, right? The whole world pays attention. So that is the impact of fine-tuning. When you are able to tune a model to a very, very specific domain, the model becomes very, very powerful in the domain. Now, to give some other examples, if you think about Bloom. Bloom model is another variant of a large language model. Bloomberg, which probably most of us Bloomberg, right? Bloomberg created Bloomberg GPT just about a few months after ChatGPT was. Now, what's interesting about Bloomberg GPT is that Bloomberg GPT, they took the Bloom model and they added a lot of finance information that they have in their archivals, and they fine-tune the model to become an expert when it comes to a finance query. So what happened was that Bloomberg GPT, when it's being launched, you can look up the news, it's all over Google. The model, even though it's small, is able to beat out a lot of the other bigger models when it comes to a finance question. When it's non-finance, okay, it may not win, and it probably doesn't win because it wasn't trained on them. But when it comes to competing in finance-related question, Bloomberg GPT is very excellent because it's fine-tuned on finance. Right now, if you take an example further, we have Sea Lion, and then there was a model that's built by AI Singapore in Singapore for ASEAN language, because a lot of the model they are good with English and but not so good with like Thai language, Burmese, Bahasa, there is Malayu, there is ASEAN languages. So AI Singapore, they created a model that specialized in ASEAN language. Right now, so to give an example, I would say is that it's like you going to see let's say if you have a heart pain, will you go and see a GP downstairs? Probably not, right? If you have a heart pain, you will go and see a cardiologist. If your children is sick, you go and see a pediatrician. If you have back pain, you will go and see an orthopedic. Why? Because they're specialized. Of course, you can go and see a GP. The GP can still give you a prescription, but you'll not be able to give you as good a prescription as compared to a specialist. So the key thing about fine-tuning is that, you are specializing a model to become an expert in the domain that you're fine-tuning on. And that's what we are going to do today, to fine-tune a model to be an expert in the edu domain. All right. Now, so with that out of the way, let's talk about what are some of the fine-tuning key terms. So when we think about fine-tuning, just very, very similar to last year's Deep Racer, right? There's not a lot of terms. So a lot of people think, oh, Vincent, wow, fine-tuning sounds a bit scary. There's a lot of things to learn. But no, right? Actually, there's only a few terms that you need to be aware of, and we're going to look at them today. The first thing first is that when you think about fine-tuning, you have a base large language model. Remember, when the thing about fine-tuning is that you're not training a model from scratch. You're taking a model that is already smart to begin with, and then you make some fine adjustment. So there is a basic model that you start off with, and there is a base model. And that could be a Llama model, that could be Mistral, that could be Anthropic model. There's a lot of other models out there, right? Basically, you have a model, a base model that you start with. So after you got a base model, what happens is that you then have the training model, which is essentially a clone of the base model, where you then it becomes like your dough, right? Then you begin to start to make adjustment to that model, right? So you have a base model, you clone it out, and then now you have a training model that you can make adjustment to it. Now, after you got a training model that you can start to make adjustment to it, there are a few ways that you can adjust it, and that's where you have different tuning techniques that we're going to talk about. You can tune it in in this way, that way, the other way, and there's multiple ways you can tune the model. Some of that is more complex, some of them is a lot more simple. But to tune a model, you always need a data set. So data set, which is the data that you want to use to train the model with, right? So data is essentially food to the model, just like how you give, let's say you talk about race horse, right? For race horse, you're going to feed the horse with food before it can run. So for your model itself, how good your model can run, it depends on what kind of data that you feed your model with. And then of course, there's like hyperparameters. If you've been in Deep Racer last year, it's something that you probably is familiar with. There's multiple different hyperparameters that you can adjust with. And then of course, you can evaluate the model. Now, these are terms. But to make it easier to understand, let's look at it through a process, right? And after that, you become as clear as the sky. Let's look at a process and see how those different terms come in together. Now, imagine you want to create an expert champion low POLYCC fine-tuned large language model. Now, but before we get there, we start with the training, right? The starting model which is the base model, right? That we pull out first. How do we get from point A to point B? Let's take a look at that. So when you're training a model first, you need to first, of course, take a base model, decide on the base model, and then clone it so that basically take it out. Then that becomes your model that you begin to start to work on, right? After you have your training model, what you do is that you're going to prepare your data set. And your data set is essentially the data, the files that you want to train the model. Now, how do we prepare the data set? Typically, your data set needs to be in a certain format. And it normally looks a little bit like this. This is across every single model. It normally looks a little bit like this. So you have a prompt, and then you have a completion. So the name sounds a bit cheap, but basically what it means is that a question and an ideal answer. So you're telling the model, okay, model, if you see a question that looks like this will be the ideal answer that I want you to generate out. And then you have a second question. If you see a second question like this, I want you to generate out an answer that's similar to this. It's almost like the exam paper, when you buy assessment book when we were younger, right? In secondary school, in high school. At the back, there's always the answer sheet, right? The question and the answer sheet. So it's a little bit like that. Basically, you need to have the question and answer and have them to feed the model, right? So the model learns how you want it to answer. Now, to give an example, so this is like a simple data set, right? Now, you can see that I have two examples over here. So you can see the first thing here, I can classify this review, and this is the prompt, right? I classify this review, I love this DVD, and then the output is positive. The second one is that classify this review, I don't like this share. The second one, then the second output is negative. So you can see over here, I got two data. Each of them has a prompt and a completion pairing. So the first one is that I love the DVD, and the completion, which is the answer, is positive. And this one is the second question, I don't like this share, and the answer is negative. So this is an example. I take this and I prepare a lot of them, and then I begin to feed it to the model. So that's how a data set looks like. But and this can apply to every kind of concept. You can change that to finance, healthcare. Basically, it's just question and answer, and you can prepare it however that you want it to be. All right. Now, after you got a data set, the next part is, okay, how do you want to tune the data into the model? There is a few ways you can tune the data. Now, the first one, you can do full tuning, which is you tune the entire brain. Essentially, you take the whole brain and it's like you restart the whole brain with a new data set, right? The second one is partial parameter efficient tuning, which is what it means is that you are taking the whole brain, but you are only adjusting a small part of the brain, right? Instead of the whole brain. So that's the idea. It's like partially updating the model itself. And the third one is the reinforcement learning, which is what we learned last year in Deep Racer, learning through trial and error, if you recall. Now, let's use an analogy again. We just had the Olympics, just finished recently, right? Some of us here, we watched the Olympics. So now, imagine you want to train an athlete to become an Olympian. How does the process look like? So the coach, one way is that, imagine I'm training for, say, running, right? I want to run for 400 meter sprint. So one way is that, first you got the athlete, the coach if you are going about full tuning, the coach will rewrite everything that the athlete know about running. Whether is it the diet plan, the running, the training regime, what to wear, the coach will basically draw a brand new training plan for the athlete to follow, right? And that is what full tuning does. Full tuning is essentially you're taking the whole model, the entire brain of the model, and you are updating every single part of the brain, right? And that is full tuning. Now, there's a second part, which is the parameter efficient tuning, which is that maybe you say, okay, the model is already quite fit, or rather the athlete is quite fit. Maybe you just need to improve the calf muscle. So maybe you introduce you just add a few more exercise reps to strengthen the calf muscle, and then get the athlete to become to be strong in a specific area. But everything else stays the same. The diet, the rest of the training regime, the athletic gear, everything stays the same, right? So I'm just changing a small part of the training regime. And that is equivalent to parameter efficient tuning. You're taking the model and you're just adjusting a small part of the model itself. Now, the third one is reinforcement learning. And to draw an example, is like, imagine someone is learning through trial and error. So instead of giving a very specific way of training that, okay, you gotta do this and that, we're telling the athlete, okay, I want you to just practice running in the mountain, practice running on the beach. I want you to basically just try out different ways of running and through trial and error, learn what is the best way that can get the best result. And that's reinforcement learning. If you remember last year Deep Racer, it was about reinforcement learning, right, through trial and error. So reinforcement learning also still applies when it comes to generative AI model training. So the idea here is that you can see between full tuning and parameter efficient tuning, full tuning, you can get a lot more control, but it takes a lot more time to tune the model, right? And of course, a bit more cost because you need more time to train. Parameter efficient tuning, you can train the model to a reasonably good degree, but at a much more optimized cost because you don't have to update the whole model. So for low competition, we're going to be focusing in the middle layer using the parameter efficient tuning technique, all right? But just for your information, there are different techniques out there. But today we are going to focus on, or through AWS LOL, we can focus on the middle one, which is also the most popular one that's being used out there in the industry. Whether it's by Facebook, Netflix, Amazon, all the big companies, they are using this technique for an efficient way to tune the model. All right. Now, so you have the tuning technique. The next thing is that you have the tuning parameters. Where you take how do you want to adjust what is the heat that you want to adjust when you are tuning the model, right? And we're going to look at them in details in a moment. And the idea is that from there, you start the training job. So the training job essentially is like an oven, right? And then after that, you then get the model out. So you will see again over here, when it comes to AI, the big part is not the training itself. Anybody can train a model because it's just a button. So it's just like turning on the oven. But the big part of how good a model is not on what happens inside the oven. It's what you do before the training job even starts, which is the steps beforehand. The data set preparation, which is the base model that they take on, what is the tuning techniques that you choose to use, what are the tuning parameters. It's almost like you're preparing to oven, right? You need to marinate the meat, right, before you can send it into the oven. And then you get out the food, how it is. So how good it is, it depends on what you do before you send the thing into the oven. So similarly, when it comes to AI model, especially when it comes to large language model, how good your model is, it depends on the pre-step before you start the training job. And after you start the job, essentially you get a fine-tuned large language model. Right? So this is how the tuning process looks like, right, on a high-level view, to see how the different terms comes together. Now, so to give a bit more example before we start to go more into the hands-on part. Now, there are different models. Every model there are different names like Llama 2, Llama 3, Mistral. So every model is a different brand of car, like Toyota, Honda, Mercedes, Cherry QQ. There's a lot of different brands. And in each of the model brands, they're what we call modality. Like over here, like say Llama, you heard of things like 7 billion parameters, 13 billion parameters, 170 billion parameters. Nowadays, there's trillion parameters. The parameters essentially is like your horsepower, like your car, the gear, the torque. What is the horsepower? How big is the brain of the model? So over here, in this case, you can see for Llama 2 or Llama 3, they have 3 different model sizes. Now, for all these model sizes, even though their model sizes are different, they're all trained on the same amount of tokens. So when these were first created, all the models were actually trained on the same amount of data. So people, they have the misconception, they think that, bigger model is trained on more data. Small model is trained on less data. Not true, right? So that is a myth. All the model, they're trained on the same amount of data. The only difference is that the team that created them, they decide, okay, how big do I want to stuff the model, the data into? So I can choose to stuff it in the bigger brain, or I can choose to stuff it into a smaller brain. Of course, you get a bigger brain, you get a better performance, generally speaking. But bigger brain also means more expensive, because the brain is bigger, it thinks slower, it needs to take longer to think, and all these other things, right? But this is basically what it means when it comes to the model. And when you look at fine-tuning, so for when they first created the model, they used about 2 trillion tokens. This is like almost generally like they crawl through the entire internet, Wikipedia, etc., to train the model, right? That's why the model are generally very good when it comes to any kind of questions. But when you do fine-tuning, remember now the example ChatGPT became GPT-3 became ChatGPT, right? They actually didn't use that much data. For fine-tuning, they use a lot lesser. In fact, less than 1%, right? So for supervised fine-tuning, what they did is that they only prepare like 100,000 data examples, which is the example that I saw earlier. And they provide that, in this case, they provide chat examples to the model to create a fine-tuned chat model. So what I'm trying to say here is that when you do fine-tuning, you don't need to have a lot of data, right? For pre-training, yes, you need to have. But when you're doing fine-tuning, because you're doing fine adjustment, you don't need to have so many. In fact, you can have as little as 50 rows of data. That's enough. But of course, the more that you have, typically the better it is, because the better the quantity, the better the quality of your data, you get back a better output, right? So that is an example. Now, to also show you a difference between a non-tuned model versus a tuned model. So on the left-hand side over here, you see what we call a non-tuned model. So for example, I can ask, now tell me how to train my dog to sit. So if the model is non-tuned, right, you will say something like, oh, tell me how to train my dog to stay, teach me how to teach my dog to come, so and so forth. And then gives a lot of like weird answers, right? Even though it's not answering my question. In fact, it's answering my questions with more questions. So let's take a step back. Let's think about it. Why does the model answer it in this way? Because the model that trained on the entire internet, including things like dog training manual, right? So when you ask the question, tell me how to train my dog to sit, the model might be thinking, okay, you are asking about what are the other ways that you can train your dog. He's not thinking that you're asking for an answer. He's thinking that you want to know more ways that you can train your dog. So when it's thinking that way, it then gives you a lot of answer. There's other ways to train a dog, right? Now, on the right-hand side, you have the tuning part, right? So if you have a tuned model, I'm going to ask the same question. Tell me how to train my dog or your dog to sit. And now I'm getting an answer that is point blank. Now, what is the difference over here? The right side model, they are trained to answer, because it's a chat model, it's being trained to answer. When you're given a question, don't answer a question with a question. Answer a question with an answer, with a direct answer. So you can see over here, because it's fine-tuned, the model knows that, okay, I should give an answer directly. So it just immediately gives you an answer. And this is just an example to show you the difference between a non-tuned versus a tuned model. If you ask the same question to any kind of model, Llama 2, GPT, Sea Lion, Bloomberg, Mishra, you get this kind of same answer. And the idea is that when you want to do tuning, you can tune not just for chatting. You can tune it further for like finance, healthcare, like the examples that we just talked about, right? Now, so we talk about the process already. We talk about what are the different ways to tune to improve a model. We talk about what is fine tuning. We talk about the process. Now let's look at AWS. How do you fine tune a model on AWS, right? So good thing first is that the idea is that when you want to do fine tuning on AWS, you can do it at multiple levels. You can do it at a very complex level. You can also do it at a abstracted level through a tooling level. So in AWS, we have a tool called AWS Jumpstart. Essentially, it's a tool that you can go inside there. It's an application. They can go in there. What you need to do is that you just need to select the model that you want to fine tune. It's like going to a shop, right? Going to like Shopee, for example. You pick a model that you want. You provide your training data set. You select your hyperparameters, and basically you just press a button, train. And essentially, after about as fast as 12 minutes, you get out your fine-tuned model, and not a single line of coding. So anyone can do it, right? We've seen as young as 13 years old doing it as well, right? So you can do it whether you got technical or non-technical knowledge. And this is the main tool that we're using during the course of the competition. Now, so after when you begin to tune a model, the next question you ask, hey Vincent, how do I improve my model's performance? How do I create the winning model? That is the That's the $1 million question, right? So the idea here is that to improve a model, it goes down to two things. Number one is that your data set's quality. So we always say when it comes to AI, rubbish in, rubbish out. So if you give your model rubbish data, you get back rubbish answer, right? So the idea is that you want to prepare good quality data to train a model. And we will show you how you can create data sets easily. We have some tools that you can create data set as well. But over here, if you are more expert, you can use more ways to prepare data set. Or we have tools that help you to generate data set without you having to write any code, right? So data set quality as well as the tuning time. Now, next we're going to talk about hyperparameters. So when you want to tune a model, first you have data set. The second thing is that we talk about hyperparameters. Now, hyperparameter essentially is like if you think about an oven. When you want to cook an oven, you can decide like, okay, how long, how hot the oven wants to be, right? And how long do you want to, what is the mode? Do you want to grill or how hot do you want the oven to be? So those are the parameters that you set before you start the oven cooking process, right? So when you think about an AI model, it's the same thing. When you do about tuning, there are different parameters that you can set before the job actually starts. And I'm going to just talk about two. So two important ones, and that's good enough for most of what you need, right? First one is epoch. So when you think about epoch, okay, the epoch name sounds a little bit buzzy, right? Basically, it just means how many repetition that you want to train the model with. So when you set the epoch to be high, so basically when the epoch is like 10, so over here, I have this is my daughter's piano book, right? So my daughter is now learning, I have 3 kids, 7, 5, and 3. My eldest is learning piano right now. So when she's learning piano, she has what we call a score sheet, right? Some of you here, you're a musician, you know what I'm talking about, you have a score sheet. So essentially an epoch, when you think about a piano setting, right? The epoch essentially how many times you want to go through the song sheet. So if you set the epoch to 10, it means I go through the song 10 times. You set the epoch to 1, means I go through the song 1 time. So now you might be thinking, hey Vincent, of course I should set the high epoch, right? 1,000, 1 million. Why would I set the low epoch? Now, you think about something like a score sheet. What will happen if you go through the same song 1 million times? So the good thing is that you probably become very, very good at the song, right? You memorize the song. But what the danger of that is that when you set a very high epoch, it means that when the next song comes along, you might have learned that first song so much that you memorize it, you're not able to adapt to the second song or a song that is different or to be spontaneous. So this is the idea about epoch. When you have high epoch, you get your model to be stable, to be more accurate on the data that you train it with. But the danger is that you might overfit it if you set it too high. Overfitting means you overtrain the model on your data such that you memorize the answer instead of understand the answer, right? So you low epoch, the pro is that, of course, you decrease the risk of overfitting, and because the epoch is low, it's cheaper and faster. Now, the question is, which one, is there a magic number? There's normally no magic number, right? So the idea is that that's where experimentation comes in, where you try to train with different epoch and see how the model result performs differently. And then from there, you choose one that is best for you, right? So that is epoch. Second one is learning rate. Now, learning rate, if you go back to the example of a piano score sheet, right? So a learning rate essentially, epoch is how many times I go through the song. Learning rate is how fast you go through it. So I can go through the song sheet, say like, in one score sheet, I can go through it in like say 1 minute. Or I can go through one score sheet one time in like 5 minutes. I go through it slowly, like note by note. 1 note, 2 note, I go through it slowly and steadily, right? So the idea of a high learning rate is that you go through your data set very, very fast. You go through like 1 page, 2 page, 3 page, 4 page, 5 page, 6 page, right? You just go through the whole data set very, very quickly. And you essentially converge very, very fast. But the downside is that you may not be so stable in your learning because you're going through it so fast, you may not be able to pick up the fine details in between the data set. So when you have a low learning rate, of course, you learn slower. But it typically means is that your learning becomes a lot more stable because you're learning it slowly, note by note. All right. So again, right, there's pros and cons, right, to both a high learning rate and a low learning rate. For both of them, there's really a default one when you first create one, but you are free to try out other ones as you begin through the course of the competition. All right. Now, so with that in mind, I want to say is that we only touch on 2, but there's a lot of hyperparameters that's available for you to choose. And we will not go through all that in detail, otherwise this workshop will be 8 hours, right? But the most important one that I want to highlight to you, all 1,500 of you, right, is that epoch and the learning rate is the most important. The rest is up for you to learn, use the competition to learn more about the other ones, right? The whole idea about this competition is to have fun, and learn, and the way to learn more is to also, beyond what is being shared to you, you can use that to learn beyond what is being covered in today's workshop. But at the basic default level, you want to know epoch and also learning rate. And in some of you here, you already have experience in data science, you know what the other means. Yeah, of course, then you can feel free to try to adjust the other hyperparameters. All right. Now, so with that in mind, let's go down to the flow. So we are done with the technical terms, right, for fine tuning. Let's talk about what is the experience like when you begin to train a model and to submit a model to a leaderboard. So first thing first is that you have what we call you have 3 environments. You have your own laptop, which I hope that you have prepared it today. You have your AWS console, which will provide 1 account per person or 1 user per team. And then of course you've got AWS LOL console. So in your own personal machine, you'll be creating your own data set. And what you'll be doing is that you create your own data set, which is basically just a file. You go into the AWS console, you go to SageMaker Jumpstart, you train the model through the no-code process, you get the model out, you take the model and you register the model to the LOL console and you submit it to the leaderboard. And then once you got the score, you can go back to the leaderboard, retweak the model and then submit again. So the whole idea is that and that's why we have this competition